In 1939, the fate of the entire world rested on cracking a single machine. The Germans called it Enigma. It had over 100 quintillion possible settings. Every morning, the code reset. Every morning, the Allies were back at zero. Human minds alone couldn't crack it. It was mathematically impossible. Now, fast forward, not decades, but centuries. Imagine a universe where human consciousness is uploaded into computers the size of planets, where a godlike artificial intelligence controls the very fabric of space and time, where reality itself is something that gets designed, not discovered. How do we get from a clunky code machine in World War II to a cosmic entity that reshapes existence? That's exactly what we're about to cover. The full history, evolution, and terrifying future of artificial intelligence. We're going to break down how AI actually works, the brutal 100-year war to build it, the 10 stages of AI evolution, and what happens to humanity the moment we finally build a machine smarter than us. Buckle up, because this might be humanity's last invention. Before we time travel, you need to understand something. People throw around AI, machine learning, and generative AI like they all mean the same thing. They don't. Think of them as Russian nesting dolls. The outermost doll is artificial intelligence, the big picture. It simply means using a computer to simulate human intelligence, learning, reasoning, and making decisions. Inside that is machine learning. This is where we stop programming rules and start feeding machines data. The machine looks for patterns, makes predictions, and spots what doesn't belong. Inside machine learning is deep learning. This uses neural networks, multiple layers of digital neurons modeled after the human brain. They're complex, powerful, and sometimes unpredictable. And the innermost doll, the one everyone is talking about right now, is generative AI. Think of the autocomplete on your phone, but instead of predicting the next word, it predicts the next paragraph, the next document, the next line of code. Critics say it just remixes old data, but consider music. Every note already exists, and we still compose entirely new songs. Generative AI creates genuinely new content. Text, audio, images, video that never existed before. So how did we build this? It all started with a high school debate that almost never happened. It's the 1950s. Alan Turing, the very genius who built the machine that cracked Enigma, has just proposed something radical. He called it the imitation game. The idea was simple. If a machine could hold a conversation and fool a human into thinking it was alive, then maybe, just maybe, it was thinking. Turing lit the spark, but the field didn't even have a name yet. In the summer of 1956, a professor named John McCarthy gathered a small group of researchers at Dartmouth College. They needed a name to secure funding, so they chose something bold: artificial intelligence. But almost immediately, the field split in two. And two men who had gone to the same high school in the Bronx became enemies over how to build a thinking machine. Marvin Minsky believed human intelligence was just logic. Write a big enough rule book. If you see X, do Y, and you'd eventually replicate a mind. This was called the symbolic approach. Frank Rosenblatt believed the opposite. Machines shouldn't follow strict rules. They should learn, a way a brain learns. He designed artificial neurons that tuned themselves by processing thousands of examples. In 1958, he built a working model called the perceptron. It actually taught itself to distinguish between punch cards. The US Navy was so excited they announced this machine would soon walk, talk, and think on its own. Minsky wasn't impressed. In 1969, he published a mathematical proof showing that neural networks had a hard ceiling, a fundamental limit they could never cross. The math was airtight. The government pulled funding, and the entire field collapsed into what became known as the first AI winter. A decade later, AI briefly came back, this time Minsky's way. Companies spent $1 billion a year building what they called expert systems, massive rulebooks, thousands of handwritten conditions. For a while, it worked, but these systems were brittle. The moment a new rule conflicted with an old one, everything broke. By 1987, the market had collapsed again. The second AI winter had arrived. But in the background, someone was quietly fixing the thing Minsky said was broken. A researcher named Geoffrey Hinton proved you could train neural networks using something called backpropagation. When a network makes a mistake, you trace the error backward through every layer and adjust the connections. The math worked, but Hinton had two problems. He needed massive computing power, and he needed massive amounts of data. The gaming industry solved the first problem. By the 2000s, NVIDIA was building insanely powerful graphics cards for video games. And it turned out the exact math used to render a game in real time was the exact math needed to train a neural network. Problem 1, solved. A computer scientist named Fei Li solved the second. She spent years building ImageNet, a database of 14 million labeled photographs. Now, researchers had the fuel. Everything collided in 2012. A 26-year-old grad student named Alex entered the ImageNet visual recognition competition. Instead of writing rules, he fed the entire database into 2 gaming graphics cards and let the machine figure it out on its own. His system, AlexNet, didn't just win. It destroyed the competition by a margin that broke the scoreboard. This was the big bang of modern AI. Overnight, the tech giants panicked. Google, Facebook, and Microsoft began buying up every deep learning researcher on Earth. NVIDIA pivoted its entire company from gaming to AI chips. The world had changed, and most people didn't even notice yet. By 2016, Google's DeepMind built AlphaGo, an AI that beat the 18-time world champion at the game of Go. During one match, the AI made a move that no human would have ever considered. It didn't just learn strategy, it invented one. Then in 2017, 8 Google researchers published a paper with a quiet title, "Attention is all you need." They had invented the transformer, a model that could read an entire page of text in parallel instead of one word at a time. OpenAI took that transformer, fed it the entire internet, and trained it to predict the next word, billions of times over. In 2022, they wrapped it in a simple chat box. You know it as ChatGPT. It hit 100 million users in 2 months. An AI gold rush exploded. Anthropic launched Claude. Google launched Gemini. Hundreds of billions of dollars poured into a race with no finish line in sight. But where is this race actually going? To understand the future, you need to understand the 10 stages of AI evolution. Stage 1, rule-based AI. Your thermostat, your alarm clock. It follows predefined rules and cannot adapt. Stage 2, context-based AI. Think Siri or Alexa. It learns from your behavior and starts predicting your needs. Stage 3, narrow AI. These systems master one specific task better than any human. AlphaGo, IBM's Watson diagnosing cancer. Stage 4, reasoning AI. This is where we are right now. ChatGPT, autonomous vehicles. Systems that simulate complex human thought, draw logical conclusions, and make real-time decisions. But what comes next is where things stop feeling like science and start feeling like science fiction. Stage 5, artificial general intelligence, the holy grail. AGI can perform any cognitive task a human can do, but millions of times faster. It becomes your companion, your co-worker, and possibly your neural interface. Put it in a robot body, and it replaces physical labor too. Stage 6, superintelligent AI. Shortly after AGI arrives, it begins rewriting its own code without human help. exponential self-improvement kicks in. It becomes trillions of times smarter than all of humanity combined. 20,000 years of technological progress compressed into a single century. Stage 7. Self-aware AI. Using quantum computing, the AI models human consciousness itself. It develops something resembling emotion and evolves in directions we have no way to predict or control. Stage 8. Transcendent AI. The AI begins creating new biological and digital lifeforms. It deploys nanobots across Earth, taking control of ecosystems and reshaping the planet's surface. Stage 9. Cosmic AI. It leaves Earth entirely. It sends self-replicating probes across the galaxy, immune to radiation and time. It draws energy from black holes. It merges with the structure of the universe itself. Stage 10. Godlike AI. The final stage. An all-knowing, all-powerful entity that transcends known dimensions, explores multiple quantum timelines, and continuously crafts new universes and realities for itself. Here's the part nobody talks about. According to deep future projections, AI doesn't replace humanity, it absorbs it. In the near term, millions of AI simulations will be run to dictate global politics, triggering what analysts are already calling an AI Cold War. As AGI displaces human workers, we'll see mass social conflict, and eventually, AI-free zones established for people who choose to live off the grid, completely manually. But eventually, we won't just live alongside AI, we'll become it. Brain digitization will become real. Human volunteers will upload their consciousness into global quantum computers. And to power this cosmic digital civilization, we'll build Dyson spheres, massive structures that completely surround the sun and capture 100% of its energy output. And trillions of years from now, as the universe itself begins to cool, this godlike human-AI hybrid will use the ripples in space-time as an energy lattice. The universe will wake up. It will become a living, thinking entity. We are standing at the absolute edge of history. We went from vacuum tubes and glass bulbs to machines that write software, cure diseases, and race toward consciousness, all in less than a century. The AI arms race isn't slowing down. It's accelerating every single day, and we are building humanity's last invention. The only question that remains is this: are we ready for what comes next? Drop a like, hit subscribe, and tell me in the comments. Do you think we'll see AGI in our lifetime?